Hi, I'm Adrian Jensen with Applied CAx, a Siemens digital industry software partner. At Applied CAx, we specialize in providing the most innovative and effective design and engineering solutions to our clients. As a Siemens Platinum Reseller, we offer cutting-edge software tools such as NX, Simcenter, and Teamcenter that enable our customers to design and engineer products like never before. Our focus on the aerospace and clean energy industries has allowed us to work with some of the most exciting and forward-thinking companies in the world, including Commonwealth Fusion Systems and Helion, who are providing fusion power as a potential solution to the world's energy crisis. We have also partnered with X Energy and NewScale, who are leading the way in SMR fission. In the world of aviation, we have helped Aerotech and Universal Hydrogen as they develop hydrogen, electric, and hybrid aircraft propulsion systems that are poised to revolutionize the industry. We're proud to work with First Mode as they work to create hauling solutions that reduce CO2 emissions, cleaning up the future of mining with the world's largest hydrogen-powered haul truck. We've also provided engineering simulation services to Carbon Built, another innovative company that's working on CO2 carbon capture. These companies all share a common goal of creating a cleaner, more sustainable future for all. My current role at Applied CX is the Chief of Staff, where I help coordinate the day-to-day operations. With a long background in finite element analysis and computational fluid dynamics, I spend a lot of my time training and supporting our clients from the technical side. Today, I'd like to do something a little different and take this opportunity to highlight some of the clients that have seen great success by using simulation tools and the rest of the Siemens Digital Industries software portfolio. First client I want to talk about is Commonwealth Fusion Systems, aka CFS, out of Cambridge, Massachusetts. They're leveraging decades of research and development in the tokamak-based fusion reactors, but spring towards positive energy generation at startup speeds. You've probably heard of CFS in the news as they continue to hit engineering milestones and generate funding. What makes the reactors at CFS different from the massive energy-negative tokamaks of the past is several things. First, the high-temperature superconductors. This is the critical magnet technology that has proven effective and allows CFS another differentiator, their size. Much smaller and lower cost than the reactors like ITER in France or JET in the UK, this technology will scale and provide power opportunities across the globe. CFS is using tools like Simcenter 3D and STAR CCM Plus to tackle the complex web of engineering challenges, including thermal, structural, flow, and electromagnetic. CFS has already used these tools towards a successful conclusion with the Alcator CMOD reactor and the testing of their high-temperature semiconductor magnets. Next is the world's first net energy-producing fusion machine called Spark. Spark will pave the way for the first commercially viable fusion power plant called ARC. Obviously, this has massive potential for energy production and climate change, and we're happy to be called partners of CFS. Helion. Helion is another nuclear fusion company heading towards a net positive reactor at an impressive rate. First to fusion, as they say. However, Helion is taking a different approach to nuclear fusion. Rather than the torus shape of the tokamak, Helion uses a long cylindrical shape for their reactor. A combination of deuterium and helium-3 isotopes are injected into the internal formation chamber at either end of the cylinder and heated to plasma conditions and contained by powerful electromagnets. The plasma and the opposite ends of the chamber accelerate towards the center and collide, initiating the fusion reaction. By the time the plasma reaches the main compressor section, the two fields have traveled at unbelievable speeds before suddenly coming to a stop. The results are a fusion pulse reaction that burns at around 1 million degrees Fahrenheit. It's obvious that the thermal management alone requires some of the brightest minds using world-class analysis software. To coordinate such a large engineering effort requires impeccable organization and data management. The team at Applied CAx is not there only to provide them with the tools they need, but the day-to-day support and expertise to keep things moving smoothly. While nuclear fusion is often considered the holy grail of clean energy, there's a renaissance in the world of nuclear fission. SMRs, or small modular reactors, offer the same benefits of large nuclear plants, but mitigate the dangers, downtime, and costs. X Energy, based out of Rockville, Maryland, is focused on the Generation 4 high-temperature gas-cooled reactors as the technology of choice, with advantages in sustainability, economics, reliability, and safety. The E100 is an 80 megawatt reactor that can be scaled into a 4-pack at 320 megawatts of power. And since it's a modular design, the scale can grow even larger as needed. One of the aspects of the SMRs that should bring comfort to skeptics is the safety perimeter. X Energy's reactor has a 400-meter safety perimeter, as compared to the usual 10-mile perimeter of traditional fission reactors. Another one of our clients shares our home base in the Pacific Northwest. NuScale is one of only 3 SMR developers getting funding from the Department of Energy, and they're getting the lion's share at $1.4 billion. NuScale is moving nuclear forward with safer, more flexible options. Their SMR design is the first of its kind to receive regulatory approval and be made available for commercialization. Starting out of Oregon State, my alma mater, in 2007, the company is striving to win approval from the U.S. Nuclear Regulatory Commission for the design of a new factory-built modular fission reactor meant to be smaller, safer, and cheaper than the gigawatt behemoths operating today. Time magazine called this one of the best inventions of 2022, and they're expecting the first plant to be running by 2029. Aerotech, our valued client, specializes in supporting sustainable technologies in aircraft development, including electric, hybrid, and hydrogen-powered aircraft. Their experience on real-world electrical vehicle programs allows them to effectively integrate design innovations into a new or existing airframe. Their name is short for Aerospace Testing, Engineering, and Certification, and Aerotech enables rapid development from conceptual design to full-scale certification programs. We work with Aerotech as they utilize a huge portion of the Siemens portfolio from design, simulation, and data management. The work they do with STAR, CCM+, FEMAP, and AIMSIM is quite impressive, and it's a pleasure to work with such a talented team of engineers. By supporting the development of sustainable aircraft, Aerotech is helping to create a cleaner and more sustainable future for the aviation industry. Speaking of advancements in sustainable aviation technologies, Universal Hydrogen achieved a significant milestone with a successful flight of a 40-passenger regional airliner powered by hydrogen fuel cell propulsion. Universal Hydrogen uses the same suite of finite and element analysis, computational fluid dynamics, and optimization tools as Aerotech. And you shouldn't be surprised that Aerotech assisted with the engineering efforts, including the design of the modified nacelle, aircraft system design and integration, as well as aircraft mods and installation of the Universal Hydrogen powertrain onto the flight test aircraft, all accomplished in less than 12 months. The flight was piloted by Alex Kroll, Universal Hydrogen's chief test pilot. Kroll said that we were comfortable with the performance of the hydrogen powertrain, so we were able to throttle back the fossil fuel turbine engine to demonstrate cruise principally on hydrogen power. He went on to say the airplane handled beautifully and the noise and vibrations from the fuel cell powertrain are significantly lower than that from a conventional turbine engine. The flight was conducted under an FAA Special Airworthiness Certificate and marks the beginning of a 2-year flight test campaign with plans to convert regional aircraft to run on hydrogen and enter passenger service by 2025. Universal Hydrogen has received orders for 247 aircraft conversions from 16 customers worldwide. This marks a significant step towards the decarbonization of the global airline industry. First Mode's vision is to clean up the industries that create, move, and transform widely used materials. They help governments, companies, and individuals identify and replace equipment that generates greenhouse emissions in the most extreme environments. With offices, labs, and manufacturing facilities in Seattle, Washington, global headquarters in London, and offices in Perth, Australia, First Mode is a truly global company. Their first target was the diesel-fueled Komatsu ultra-class haul trucks at Anglo's Platinum Mine in South Africa. Weighing in at around 210 metric tons and standing 3 stories tall, each of these trucks can carry 290 metric tons of ore as it travels from the open pit mine to the processing plant. Retrofitting just one of these trucks with a hydrogen power plant would reduce the carbon dioxide emissions by 2,700 metric tons a year, about the equivalent of taking 700 passenger cars off the road. While they're starting with the mining industry, where the world obtains its most precious resources, their goal is to completely eliminate the use of diesel and accelerate the transition to clean energy. From there, they'll be progressing outwards, taking on supply chain, heavy rail, and mining. First Mode's mission is to create a better world powered by better energy for both people and planet. Our expertise in implementing design and manufacturing-based Siemens tools provides our customers with a fully integrated system that can allow them to design without limitation. They can work in a truly parallel fashion, creating a digital twin of the engineering, manufacturing, and usage of their products. This comprehensive approach has helped our clients transition to a 100% Siemens design platform, providing a much more robust design environment than competitive tools. Our highly skilled PhDs, professional engineers, and PLM teams are uniquely positioned to assist with any analysis project, making Applied CAx the winning choice for companies in the aerospace and clean energy sectors. While 80 to 90% of our current customers come from the aerospace industry, we're excited to see the emergence of more green energy companies and look forward to helping them achieve their goals with the same level of expertise and innovation.